So, Chapter 6 is about quadrilaterals, and so the first section is trying to have you use the polygon angle sum theorem. And so the first one says, the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. So we're going to find the sum of the measure of an interior angle by using that formula. So here's my first problem. It says, what is the sum of the interior angle measures of a heptagon? So the first thing is knowing how many sides a heptagon has. A heptagon will have 7 sides, so that means that n will equal 7. So all you have to do is just plug 7 into your formula. So I put 7 for the n, and then just solve it. So 7 minus 2 would be 5, and then take 5 times 180, and I would get 900 degrees. So that means all of the angles in a heptagon will add up to 900 degrees. Now I want you to pause the video and try the got it question. So the got it question is asking, what is the sum of the interior angle measures of a 17-gon? So they already told you how many sides a 17-gon had is 17. So I'd put 17 in for n and then just solve it out. So 17 minus 2 would be 15. Take that times 180 and I would get 2,700 degrees. So that's using the polygon angle sum theorem. Next, we're going to talk about some vocabulary. So the first is, what does it look like if I have an equilateral polygon? That is a polygon with all of your sides that are the same. If I have an equiangular polygon, that means all of my angles are the same. And if I have a regular polygon, then that means the polygon is equilateral and equiangular. So all the sides are the same, all the angles are the same. The next theorem is a corollary to the one we just got done using. It says that you can find the measure of an interior angle, so just one of the angles, in any polygon by using this formula. So notice it's the same formula as before, but now you're going to divide by how many angles or sides you have. So problem number 2 asks us to find the measure of each interior angle in a regular hexagon. So first you would need to know that a hexagon has 6 sides, so n would be equal to 6. So in my formula, here is my original formula. I plug in 6 where I see n. So I put 6 there, and then start solving. So I do parentheses first, so I would get 4 times 180 over 6. Do that product, so it's 720, and then divide it so that I get 120 degrees. So what you just found is that each angle in a regular hexagon will be 120 degrees. Now pause and see if you can do the got it question. So in the got it question, it's asking, what is the measure of each interior angle in a regular nonagon? A nonagon is 9 sides, so I would plug 9 in for n. So here would be my original setup. Do my parentheses first and get 7 times the numerator, and then end up with my answer, which is 140 degrees. Problem 3 is where you're starting to apply both of them. So it's asking, what's the measure of angle y in this pentagon? So I'm trying to figure out what this angle right here would be equal to. Well, first thing is, I know 4 of my 5 angles. So it's kind of similar to our triangle questions, that if you know 2 of the 3, you can find the third. Well, if I know 4 of the 5, I can find the 5th. So I would want to add up all of my sides, or all of my angles, I should say, and then set it equal to how much a pentagon will have for all of the angles added up. So to do that, I have to use that first theorem. So since it's a pentagon, I would do 5 minus 2 and then take that quantity times 180. So all of the angles in a pentagon will always add up to 540. So you can either just do some simple math on your calculator, or I set it up as an equation. So here's 4 of the angles that I have. Here's my 5th angle I'm trying to find. So I combined my like terms, and then I subtracted it to find what my missing angle is. You pause the video now and see if you can find the measure of angle G in the got it question. So first thing I would do is notice I have a quadrilateral, so I'd want to know how much all of the angles will add up to in a quadrilateral. So using my formula, I found that that would be equal to 360. So all of the angles would be equal to 360. And then just do some simple math. So I added 120, 85, 53 and got 258, and then subtracted it from 360 and got 102. The last piece of this lesson is the polygon exterior angle sum theorem. So that says the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So what that's saying is that every exterior angle in a regular polygon will always be equal to 360. So in problem 4, it asks me, what is the measure of angle 1 in the regular octagon at the right? Well, first knowing that a regular octagon means all of my angles are equal, so if all of these angles are equal, then I know that all of these exterior angles have to be equal to each other as well. The other thing is it's an octagon, so that means I'm going to have 8 sides and 8 angles. So what you can do is, if all of those angles are the same, they also have to add up to 360. So I can just do a simple equation, 8x equals 360, and divide it by 8. So each of these exterior angles would be 45 degrees. Pause the video and now see if you can do the got it question. So in the got it question, what's the measure of an exterior angle of a regular nonagon? So a nonagon has 9 sides, which means it would have 9 exterior angles. So all I would have to do is take 360 and divide by 9, and that would be equal to 40. So that concludes the first section of Chapter 6, kind of introducing to you some formulas for finding the angle sum. If you have any questions, please let me know so that I can help you. Otherwise, you will start on your assignment.